last lesson of the entire year. Feels kind of funny, I guess. I don't know. I'll miss coming out here and filming a little bit. I'd much rather teach you guys live. Okay, solving exponential equations is actually another topic that we're transitioning out of grade 11 from the exponential unit. So this page here, so the first 5 examples that exist on your note looks like this. It's got Al Gore in the bottom and some singer up top that I don't know. The first 5 examples are all grade 11 examples of solving exponential equations. Then, once the exponentials get a little difficult to solve, we're going to introduce using logs to solve them. And if this had been a natural progression of this course, the next lesson would have been more about solving logarithmic equations, but we just don't have time for it, so it's getting cut out. But we want to keep the focus on kind of the transition between exponential and logarithms, and again, how closely they are related through their inverse. So just some basic things about solving exponential equations. When you look at these, they should look familiar in that we did, for the most part, especially if you had me as a teacher, address them in grade 11. So you would have said something like SPBEP. I used to say that all the time. Same base, equal power. If you can get them to have the same base, you can equate their powers. So in grade 11, when I taught it, I sort of talk about group numbers. So group 2 numbers, or base 2 numbers, are 2, 4, 8, 16, 32, 64. Base 3 numbers are 3, 9, 27, 81, 243, etc. Base 5, 5, 25, 125, 625. And when you see those numbers, you should recognize them as their base number to see if you can equate. So right here, obviously this is base 3. I can't simplify a 3 any more than that. And when I look at the number 81, right away it should in my head go, oh yeah, that's a base 3 number. 3 to the what specifically? So you may have to use your calculator and look into it and say, well, it's 3 to the power of 4. Once you find that it's 3 to the power of 4, once they have the same base, you can equate their powers. So in grade 11, I always wrote that kind of step down. That's not necessary to write down, but maybe the first couple times just to remind yourself, when you have the same base, you can equate the powers. Okay, you can go right from this line to this line. You don't have to write SPBEP. Okay, but that's just sort of the general idea. So if you use the most basic example, it starts to be very clear what we're doing. Now, if you complicate it slightly by, say, putting a number out front, you're still going to solve in the same way we've always solved equations. So in grade 9, you would have said something like, well, there's a multiplication here. I want to undo the multiplication. And to undo something, you do the opposite. So the opposite of multiplication is division. What you do to one side, you do to the other. This cancels. You have 3 to the x left on this side and 243 on this side. Again, I have to make them have the same base before I can do anything. If they don't have the same base, I can't solve them. So this becomes 3 to the power of 5. And again, once they have the same base, you can equate the powers. Okay, so it's very straightforward. I don't think it's overly difficult at all. I think it's in all of our realms to do. Now, you will get some where they start to have more complicated exponents. That doesn't make the question any more difficult. Just take the time to look at the 2 bases as they currently exist and figure out what you have to get them down to. So here I have a 4 and a 2. Well, clearly they can both go down to base 2. Here I have a 9 and a 27. They can also go down to a common base. This time it's going to be base 3. So you kind of have to look and see, in what way do I have to do this? So in order for me to keep this one stays the same, it's already base 2. How do I make a 4 base 2? Well, I can replace the 4 with 2 squared, keep the exponent the same, and that will allow me to sort of figure out what's going on here. So if I just expand this 2 in, okay, so just distribute it. So I really have 2 to the 2x plus 2 is equal to 2 to the x minus 1. Again, you're using SPBEP. Once they have the same base, I can equate the powers. So 2x plus 2 must be equivalent to x minus 1. Now it's just a linear equation to solve. Bring all the x's to one side, becomes negative. Bring the 2 to the other side, becomes negative, and I have x equals -3. Okay, Again, not overly difficult, but you have to be used to the idea that you're going to be sometimes reducing both sides of the equation to a common base, and maybe the base doesn't exist in the equation right then. Once you get them to the common base, though, it's quite easy. And if they don't have a common base, if there's no common base you can come to, that's when we're going to introduce logarithms. So we'll see that in a minute. Okay, in D, you have it set up. You look at the 9 and the 27, you're thinking, well, 9 and 27 are related. Maybe I'll make them both base 9. But you can't put 9 to any exponent to get 27. They're not related in that way. They both have to be brought down to base 3. So 9 can be rewritten as 3 squared. Keep the exponent the same, 3x plus 1. 27 can be rewritten as 3 cubed. Keep the exponent the same. So now, again, if I distribute, I'm going to have 3 to the 6x plus 2 equals 3 to the 3x. Okay? Once they have the same base, you can equate the powers. 6x plus 2 equals 3x. And again, now it's just a linear equation. Bring all the x's to one side. Change signs where necessary. 3x equals negative 2. X equals negative 2/3. Okay? So all of these came right from the grade 11 curriculum. In fact, came right from a note we do in grade 11. It's sort of, if you're in that unit and you're short on time, it might have been something that your teacher didn't address, because it really shows up in the grade 12 curriculum, but it's so closely related to what we're doing in grade 11 at the time that if there is time, we like to do it just so you've been exposed to it already. Okay, E is the one that's going to present some issues. I don't think a lot, but in the way that right now you now see x is on 2 different exponents and they're on the same side, separated by a subtraction symbol. And you're going to have to use a little bit of knowledge about exponent laws in order to solve this. So basically what we have to do is when we look at 3 to the x plus 2, we have to remember that this came from an exponent law that said 3 to the 2 times 3 to the x. So the idea was that if you have 2 values with the same base, when you multiply them together, you add their exponents. Okay, so that happened here. We'll put the x first, like it was written. Okay, so if you multiplied these together, so forget this existed for a second, pretend this was the question. If you multiplied these 2 values together, the base remains a 3, you add the exponents, x plus 2. So I haven't changed the question at all, I've just changed the way I looked at it so that something becomes glaringly obvious. It's that these now have something in common, right? They both have a 3 to the x in them. So if I factor out the 3 to the x, then here I'm left with a 3 to the 2. Here I'm just left with a 1. I took the whole 3 to the x out, I'm just left with a 1, equals 216. Because the problem here is that currently 216 is not a base 3 number, so I couldn't do it as easily as just limiting that. So I now get 3 to the x. In here, 3 squared is 9. 9 minus 1 is 8. Is 216. And now comes a question just like this one. How do I get rid of this multiplication by 8? I divide. Those cancel. I now have 3 to the x equals 216 divided by 8, which is 27. And now I can convert them to both base 3 numbers. And I can say that x does definitely equal 3. Okay, so that's sort of the issues that you may encounter, is that if there's ever an addition or subtraction, that's going to cause a problem right away for you, because you can't just equate them and then make their bases the same. So look for, if there's an addition or subtraction, somewhere you can factor the x exponent out so that only one of them exists. That's what's going to make the question a little bit easier to solve. Okay. Easy to get to the same base, easy to get to the same base, easy to get to the same base, easy to get to the same base. Took some thinking, eventually easy to get to the same base. You will run into questions, and that's where the next ones come in, where you cannot get them to the same base. And that's where we're going to introduce the logarithmic way to solve, which actually makes your life pretty easy. And we're going to go with the the common log, which is the one that we call base 10. Okay, the one that your calculator can solve, because we're going to be using our calculators again to solve these. So let's see which questions I want to do. We are on F. 3 to the x equals 100. Let's do that one first. So when you look at a question like this, 3 to the x equals 100, very similar setup to the first one. The first one said 3 to the x equals 81. And I looked at the 81 and said, yes, it's a base 3 number. I can get it down to base 3. When I look at the number 100, you know right away 3 to any exponent is not going to equal 100. Okay, so right away this causes a problem in that I can't get them to the same base, so I cannot equate the powers. So what we do here is we take the common log of each side. So what that means is I'm just going to write log in front of them. So I put a log in front of the 3 to the x. I'm going to put a log in front of 100. So this is considered take. And remember the word common log means base 10. Okay, so you take the common log of each side. That's an allowable thing. It's just like multiplying both sides of the equation by 2. Adding a 3 to both sides to solve it. So whatever you do to one side, as long as you do the other, is fine. Now you're saying, well, that looks way more messy. Now, what's going to make it a little bit easier is right now, this exponent is up here. But remember the law from 8.4, it was called the product law, or the power law, sorry, where you can take this exponent here and bring it out front. So I can write the x here and then keep it as log 3 equals log 100. Okay, so here I use the power law to bring the x down. And now it becomes a really easy question, because now I just have to say, well, how do I get the x by itself? It's being multiplied by log 3. Well, log 3 is just a number. In fact, if you have your calculator, you can look at it right now, and I put log 3, because I know that it's the common log, and I know that's 0.477. So if this was any other question, you said, oh, 0.477x, how do I get rid of the x? Well, I divide by 0.477. Okay, easy. Same thing here, it's still in log form. If I want to get rid of multiplication by log 3, I divide both sides by log 3. That gets eliminated, and now I would highly suggest you leave the logs till the end and do it all in one step. So I'm going to do log 100 divided by, I like to use brackets, log 3. Make sure, try this with me with your calculator, make sure you get the same answer. And I get a final answer of, oops, hold on, log 100, which is 2, divided by, in brackets, log 3 equals 4.19. Okay? So yeah, there was no way you were going to know that x was 4.19 by just doing trial and error. This would have been an impossibility. So we did do questions like this in grade 11 where I said just find, they were like word problems. I remember there was kind of a classic one that's on a lot of tests that talks about the price of a chocolate bar. And you have to anticipate what the price will, in what year the price of the chocolate bar becomes $2. And you have to keep putting in different x values till you find out. Well, that could have easily been solved using logarithms. The problem was in grade 11 you didn't know about them. So now it becomes easy. If you look at the question and you can't get the same base, take the common log of both sides. Okay, so we're going to see it a couple times. As we go through them, they're going to get obviously a little more difficult. So this one is 2 to the x plus 1 equals 3 to the x minus 1. Well, it's very clear in this question that there is no way that 2 and 3 can become the same base. They're already in the reduced base mode, and they're not the same. So what we do is we just take the log of both sides. You change nothing except for writing a log in front of it. Don't touch the exponents yet. Do nothing else. These are common logs. Remember, they have a 10, base 10 there. Once you take the log of both sides, the next step, use the power law. Bring the exponent to the front. I would suggest putting it in brackets so you don't think just the 1 is in front. So x plus 1 comes down times log of 2. And that equals x minus 1 times log of 3. Now you're saying to yourself, that does not look any cleaner. But log of 2 is just a number. Log of 3 is just a number. So if it was any other situation where we had a number, we would back distribute, right? We would multiply this into both of these values. Okay, that will allow us to kind of get our x's together, kind of get our numbers together. So really what I have here, if I back distribute, I get x times log 2. And then I get plus 1 times log 2, which is just log 2. Over here, I get x times log 3 minus 1 times log 3, which is just log 3. And now this is a linear equation to solve. X's are in linear mode. There's no exponent on them whatsoever. It's a matter of using grade 9 solving equations. Yeah, there's logs there, but it's just a fancy button on your calculator. Bring all the x's to one side, all the numbers to one side. Remember, these are just numbers. And solve for x. So I'm going to leave this x here. I'm going to bring this x over. It becomes negative. And on this side, I already have a negative log 3 here. I'm going to bring the log 2 over. It also becomes negative. To solve here, I'm going to have to factor out the x. So I get log 2 minus log 3. Negative log 3 minus log 2. And then the last step, how do I get the x by itself? I divide by whatever is here. So I'm dividing by log 2 minus log 3. If I do it to this side, I must do it to this side as well. Those cancel. And now I have a little bit of arithmetic to do on my calculator. So I take my negative button, negative log 3 minus log 2 divided by log 2 minus log 3. Use brackets, please, or else you're bound to get a wrong answer. And I get 4.4, close to the last answer, 4.42. Okay? But nothing really new. Really the stages of this are, take the log of both sides, use the power law, bring it down. After that, it becomes an ugly looking linear equation to solve. It's not ugly. These are just numbers. Okay? You're going to get the answer wrong if you simplify these too early. So just leave all the logs there till the last step to make sure you get it to the proper decimal place. I'd hate to take half marks off because you rounded early unnecessarily. Okay. I think that's pretty clear. The last thing is introducing a little law, and then we're done the course, just like that. Don't know where the time went, honestly. It's shocking. I know you guys probably feel tortured being at home nonstop. I mean, things are loosening up a little bit. But if you think of it from the perspective of, say, my kids' age, Morgan's just about to be 7 and Ben is 8, they think this is the greatest thing that ever happened to them. They get to stay home with me every day. They get to go swimming every day. They get to play outside every day, go for walks. I don't know. You have to look at it from perspective of all different people that are being affected. And there's certainly people that are being affected in a much worse way than we are. But for little kids, they think it's great. Okay, the next one. Solve x equals log 338. So this is like bringing us back to something that was happening yesterday. So in order to solve this, we have to put it back in exponent form. So remember, putting it back in exponent form, the 3 remains the base. 3 to the x gives us 38. Now that we've learned some new things, we can put it back into log form by taking the common log of both sides. And again, applying the power law, the x comes out front. And then to get the x by itself, we divide both sides by log 3. And what I really want to look at here is, yes, I can plug this into my calculator, which I will to get a final answer. Log 38 divided by log 3. 3.31. But the real thing that we are interested in is this. Oh. Hey, Morgan. And how it's related. I'm almost done, babe. It's good. It's nice in here.
What?
It's nice in here. Okay, I'm almost done. This and how it's related to this. So this said x equals log base 3 of 38. Now when we come down here, notice, oh, here's the 38, here's the 3, here's the x. And this actually becomes a law. So it doesn't really matter what your base is. We're going to call it base A, as we always do. And the value over here is x. And that is always going to be equivalent. So basically, if we sort of eliminate these x's right here, obviously x is x, that this log ax is going to be log of x over the log of a. Okay, so just take a look at this here. If this is x and this is x, then that means they're both equal, which means these sides are equal. Log base 3, 38 is log of 38 divided by log of 3. Okay? So whatever the value is here, it goes in the numerator. Whatever the base is, it goes in the denominator. And that will allow you to solve a bunch of different problems. So even on this one alone, there's 2 little examples to end off our year. Okay, if we go to solve this, obviously our calculator can't do this. Our calculator can't do this because it's not in base 10. But we can take whatever base it's in and turn it into the ratio of 2 things that are in the common log. These are both base 10 now, right? So I can say, well, this is the same as log 7 over log 3, which I can do on my calculator. So this is key. This is key to allowing us to take any base log and turn it into the common base and being able to solve on our calculator. So you can do any of these questions now. And obviously, if you just do log of 7 divided by log of 3, 1.77. Okay, and then the last one of similar nature, just to see it again. There's a daddy long legs. Well, go away from it. Problems. Okay. So log base 9, we can't do that on our calculator. We have to convert it. I'm almost done, Morgan. Log 400 over log of 9. And again, you go to do that on your calculator and you get 2.73. Okay? So we're really looking at, in a whole compass of things here, how can you solve exponential equations? And then how can you use logs to assist you where it's not easily to solve in exponential forms? And that's the idea. You can go back and forth between exponentials and logs and exponentials as much as you want and it makes your life quite a bit easier. Okay, that is our course. We are probably a heavy unit behind where we should be in that we cut 2 to 3 lessons out of the last couple units. So we cut a little bit out of 6, quite a bit out of 7, and quite a bit out of 8. But that's the way it's going to go. If you are coming back next year and taking calculus, then as long as you've put an effort in here, I think you'll be okay moving forward. We took out things that were not going to impact your calculus careers. If this is the end of your line for math, then congratulations. And obviously, good luck if you're going to post-secondary next year. And hopefully we'll have a graduation in the fall and we'll be able to see you all again. Okay.